Students, welcome to ePhysics. Students, in this video, we will be discussing two important topics. Okay, the first topic here we have is the electric field intensity, and the next topic we will be discussing is the electric dipole. Now, students, let's start with the first topic, that is the electric field intensity. Now, if we go into the definition of it, it is the strength of electric field at any point. Let us consider we have an electric field, and in this electric field, if we talk about any point, this point, what is the strength of electric field in at this particular point will be considered as the electric field intensity at that point. So we can write it as it is the strength of electric field at any point. Or we can also write it in the another way, that is the force experienced by the test charge, that is the force experienced by the test charge placed at any point in electric field, placed at any point in electric field. Also, students, now if we are supposed to write the formula, it is a vector quantity denoted by capital E vector will be equal to, it is the force by, let us consider the charge is Q naught. So in Q naught, if we are supposed to find the electric field intensity on charge Q naught placed at any point in the electric field, then the electric field intensity will be equal to force or that charge, point charge or any test charge, divided by the magnitude of the test charge. So this is the formula of it. Now let's see the formula. If we have a charge, let us consider capital Q, and due to this charge Q, what is the electric field intensity at charge Q naught, which is placed at a distance r, from this capital Q charge. Okay, so let us name the points first. Let us consider this is point O and this is point P at which the charge Q naught is placed. Due to charge capital Q, the force on this Q naught will be on this direction. This is the force, okay, this is the distance. So the distance r vector we have taken it. So the force on Q naught, due to capital Q will be equal to F. From Coulomb's law we know that it is equals to 1 by 4 pi epsilon naught magnitude of the product of the charges, that is here we have capital Q and Q naught. So capital Q and Q naught divided by the square of distance between them, that is r square. So what is the direction vector, unit vector will be r cap. Okay, r cap. So this is the force according to the Coulomb's law that we have studied already, and we know that electric field intensity is equals to force upon Q naught. So the electric field intensity will be equal to force, the value is 1 by 4 pi epsilon naught Q naught upon r square. Okay, r square divided by Q naught, and then we have this r unit vector. This Q naught and Q naught gets cancelled, so we are left with electric field intensity due to a point charge. Okay, electric field intensity due to a point charge will be equal to 1 by 4 pi epsilon naught Q upon R square r cap for the unit vector. Is it clear? I hope the thing is clear to you all. Now let's move to the next topic, that is the electric dipole. Now students, the next topic we have in this video is electric dipole. So what does electric dipole means? Di means two. Okay, di means two, and we have two poles, therefore we will be having two charges. Two poles means two opposite charges. Okay, so one will be the positive charge, other will be the negative charge, and the intensity, or we could say the magnitude of both the charges will be equal, of equal magnitude. Okay, two charges of opposite sign but equal magnitude, equal magnitude. So how can we define electric dipole? So it is a system of two equal and opposite charges. Okay, it is a system of two equal and opposite charges separated by any certain distance. Separated by any certain distance. So if we draw the diagram, we can see, let us consider we have two charges. Let us consider that is minus of q, plus of q, and both the charges are separated by distance. Let us consider r, and if we consider a midpoint o, then this distance will be a, this is again a. So this r distance between minus q and plus q will be equal to twice of a. Okay, twice of a, and the direction will be from minus charge to the plus charge. Is it clear? Now this is the electric dipole. Now what is electric dipole moment? Now students, what is electric dipole moment? Okay, when we talk about the electric dipole moment, it is denoted by p vector. It is denoted by p vector, and we can define it as, it is defined as product of either charge and the distance between the dipoles. Distance between the charges, that is the length of the dipole. Okay, charges. So as we have discussed, it is denoted by p vector will be equal to either charge, product of either charge. Either charge means either minus q or plus of q. We don't take the next sign over here, we only take the magnitude, that is q, and the distance between both the charges is 2a. So it is q into 2a. Clear with this? So this is electric dipole moment. Here the unit of electric dipole moment will be equal to this charge. The unit of charge is coulomb and unit of distance is meter, so it will be coulomb meter. So I hope, is it clear? I hope it is clear. Sorry. Now you can see it, we have discussed two things. One, the electric field intensity, we have discussed the definition, the formula, and the formula for a point charge. Okay, the intensity of the point charge, and then with the next topic we have discussed electric dipole and electric dipole moment. So that's it with the video. I hope you understood it. Thank you very much for watching.